Okay, so welcome everyone. You all know me, I think, but I'm Professor Dierbach in the Department of Computer and Information Sciences at Towson University. I appreciate being given the opportunity to talk about Python. I'm sure you've heard about Python. It's now ranked as one of the top or second to the top most popular language. Like all languages, you know, it has its appropriate applications. It's very different than Java, but Java is really meant for really large scale software engineering projects, which Python isn't necessarily that suited for, but there's lots of applications of Python that are going on, and lots of code that's been written for producing libraries for people to use, lots of code libraries. So I have a slide presentation. If you wanted to try things as we go through it, one site I would recommend is the Repellet site, which, let me share my screen. So the Repellet site is free. I think you just have to provide your email address. But what's nice about it is it supports about 40 different programming languages, and it's very, very easy to use, and displays the code very clearly too. So you'll see some choice of languages if you go to the site, but there's like I said, over 40 languages you can run on there. So you could run Python. The free account doesn't run quite as efficiently as if you get a hacker account. Students can get a free hacker account, but you have to, I think, subscribe to GitHub first, and then through that you can get a free account. So there's a couple hoops to jump through. So you get, the main thing is you get faster execution of programs if you're a hacker account, but otherwise it's still pretty usable. So because Python is interactive, you can type programs in here and run them by just clicking run. So comparing that to the smallest possible Java program, you can write programs in Python with just one line. And because it's interactive, you can type things in right in this in the shell window and try out instructions, which is something you might do as I go through things to try things out. So that's one possible site to make use of. So interrupt me at any time with any questions. It's a workshop. It's not supposed to be a formal presentation. But everything I will demonstrate will be through slides mainly. And then at the end, I'm going to demonstrate some code right within Python. Okay, so what I'm going to do is really give you sort of telling you what you need to know to learn Python. So I'm not going to try to teach you Python step by step, but what are the things you really have to know about, and what are the things you need to look up, and give you some links to resources. I'm only going to assume that you have knowledge of functions. I'm not going to talk much about classes in Python, how that's done. So as long as you have knowledge of functions in programming, that should be enough. So I'm going to give a history and overview of Python. I'm going to describe the Python data model, which is really central to Python, to understand what data types you're given, and a lot of support around that. That's a big part of Python. And then I'm going to give you some example code, or as we go through, we'll look at examples. And code that's written well in Python is called Pythonic code. So there's a real emphasis of Python on readable code, concise but not cryptic code. And so we'll see that. So as far as the history, this is the guy that developed the Python language way back in 91, which may be farther back than you would have thought. He was initially involved in a project with a language called ABC, which was a 10-year project before that. And the emphasis of that language was on readability and clear code. And as long as I'm mentioning, clear code and readability, most code is going to end up having to be modified. So when code's developed, we don't think of it as etched in stone that it's working and then that's it and we just distribute it. There's always reasons to update it. And it oftentimes may not be updated by the person who wrote it. So that's why there's a real emphasis on code that's readable and easily modifiable or easily modified. So when you're talking about well-designed software, that besides the fact that the software works and does everything that it should do, there's one of the main goals is that it's readable and again, easily modified. He was working at Dropbox until about a year ago when he retired. Dropbox is written in Python, like a lot of other things are. He was known as the benevolent dictator for life of Python. So that title for a language means that if there's disputes about any new additions to the language, he gets the ultimate say in those decisions. But he stepped down from that role just recently too. So he's technically retired now. He named Python after the British comedy sketch show Monty Python's Flying Circus, which was basically in the early 70s. So you may or may not have heard of them. I just learned by researching for this talk that there's actually a module in Python called the Argument Clinic, which is one of the famous sketches that they did, or skits that they did in Monty Python Flying Circus. So I thought to pay homage to Guido von Rossum. It's a short few-minute skit that I thought we could look at to get things rolling. So that's on YouTube.
Distance has been on all of our minds lately.
And we'll skip the commercial.
Too close to.
Okay, so there you got a taste of Monty Python. So let me bring up the slideshow again. Okay. So I already mentioned that Python was an outgrowth of a project called ABC, which I said was a 10-year project before Python. Python's an open source language. The site to go to the starting point for the Python would be to go to this site, python.org. And that's where you would be taken. And if you go directly to documentation, you'll see it's laid out that there's beginner's guide, moderate, advanced, and all the information, generally the main information would be linked from here. So that's what you would go to download and get documentation on Python. The features of Python, I already talked about the fact that it's focused on readability. As a matter of fact, if you search Python and executable pseudocode, you'll find a lot of hits because the syntax of Python is so natural that it's as if it's pseudocode. It's interactive, which I showed. It's portable. It can run on a lot of different platforms and run identically. It's dynamically typed, which is a well-known aspect of it, which you can assign a variable to any type of value. You don't declare the types of variables. So when people get into religious wars about languages, that might be one of the things they mention, that Python's no good because it doesn't have typed variables, and typed variables help the programmer from detecting errors in a program, but it provides a lot of flexibility. And that's why I said in the beginning, Java is good for engineering million line programs. Python would not be, but Python offers flexibility that's useful for a lot of applications. Python's implemented in the C programming language. Another thing that people will mention about Python if they want to argue about languages is that in Python, indentation counts. The amount of indentation is what indicates program blocks. So in other words, which statements are within a while loop doesn't depend on using curly braces, but it depends on indentation. So we'll see that. There's a large standard library of modules available, but there's an awful lot of third-party modules for doing all sorts of things in Python. And there's built-in support for doing GUI programming called tkinter. Python was a little unusual in that there were two versions of it being supported in parallel, Python 2 and Python 3. That was going on for about 10 years. Finally, they're dropping the support for Python 2, forcing everyone to use Python 3. The reason why Python 2 held on for so long was because there were so many library modules written in Python 2 that were not rewritten or ported to Python 3, that Python 2 remained supported. But now Python 3 is the only version that you should be looking at. There are not huge differences between the two, but there are differences that force code to be rewritten. So for instance, in Python 2, the print statement, you use the print keyword and then no parentheses around what you're printing. In Python 3, you do put parentheses around. So since print is so commonly used, any program in Python 2 would have to be rewritten for Python 3. The documents that are available to look at, I actually showed you that from the python.org site. This is a direct link to the documents, and that's where it had documents from beginner to intermediate to advanced. The primary reference, once you're up to speed with Python, is there's a language reference, and then there's a reference to the standard library. So this is what the language reference looks like. Expressions, some of the basic statements, the control structures, that kind of thing. And then the library, the standard library, is provided here. And here's a library for string operations, library having to do with Unicode, lots of things here, date, time, calendar, data compression like zip files, a lot of them for networking, the internet, and HTML. But anyway, those are the standard modules. And then there's, like I said, lots of other modules available from third-party sources. Trying to find places in the presentation to mention certain things. So when you write your own Python code, you can document it by making use of what's called a doc string. A doc string is any string within triple quotes. Python allows you to use single quotes for strings, double quotes for strings, or triple quotes. And the way you do triple quotes is either to use 3 single quotes or 3 double quotes. And so that's referred to as a doc string. If you have a doc string within a function, let's say, then the help function will be able to display the information about that function. So here's an example. If I have a simple function, so declaring a function in Python, we use the def keyword. We give the function name. We don't declare a return type, but we can return any type we want. We have parameters. We don't declare the types of the parameters because they can be anything we want to give it. And then the next line, if there's a docstring for this function, would be the very next line, and it's indented because, as I said, the body within a function or the body within a while loop has to be indented. So the colon at the end of this first line, when you're in Python and Python editor, will automatically indent when you put the colon. But when there's a colon, that's another way to tell you that what's after that should be indented. So here's the docstring. It's in 3 double quotes. There is a convention in Python of using double quotes for triple quotes and not single quotes, but that's just a convention. And then I'm just saying, add the 3 up, divide by 3, and that's the function. So now because I've added that docstring, I can either print directly from the function name, I can get the docstring and print it, or within help, if I put the name of the function, my own function, and call it with help, it will print this out, which is basically printing out where the function is in module main, and then the function header, and then what it does. So that's kind of nice that you can automatically have documentation generated from your functions or your modules or your classes, things that you define. So I mentioned that Python is an open source language. And so one interesting fact is that in 2015, in the primary schools in France, when parents were asked what they thought was more important for their kids to take, French lessons or Python, 60% of them, 6 out of 10, prefer their children to take Python instead of French. So it's a pretty standardized language there in the school system and also in Britain, I know. I already mentioned that in most, Python ranks as the first or second most popular language. So if you look at most rankings, it's going to be up there as first or second. Python is used all over, but just to mention some companies, the Amazon, Facebook, Google, and so on, these are companies that use Python. So Python is a hybrid language. So you can program in it in one of three paradigms, or a mixture of them actually. You can use it strictly as an imperative language or a procedural language and not use classes and objects. It has object-oriented features, so you can make use of that. And it also fits into the category of functional languages. So if you hadn't had 455 yet, or if you haven't seen these paradigms, a functional language is another way of programming where everything in the program is a function call, so that the program ultimately becomes kind of like a composite function. So Python, these are not functions in the sense of when we think of methods as functions. Functions in functional programming are what are called first-class citizens. So if it has functional programming features, that means you can treat functions as if they're as the same way as you treat other data like an integer. So that means you can pass a function to another function as a parameter. You can pass a function as a parameter to another function. Or you can assign a function to a variable and have it stored in a variable. So it's got features in like that also. You probably have heard of Python used a lot in the data sciences, and this, because you hear a lot about deep learning, a lot of mention of Python in that context. Python's the biggest language in the traditional sciences. It's very big in the data sciences. It's taking over some languages that were specifically for data science or data analytics, like the language R, and it's very big in machine learning and AI. It's used in almost all applications, but here's just some other mention. Django is the framework, a Java framework for doing web development. PySoy is for 3D gaming. with Python. Tinker is the GUI library that I mentioned. Looks like I copy and pasted and forgot to update this, but there's a version, there's modules in Python supporting computer-aided design. There's embedded applications. Raspberry Pi is a small one-card computer system that you may have heard of, and it's got embedded Python in that. Because Python, the interpreter of Python is based in C, allows it to be embedded more easily in different devices. Some particular modules, I said there's a lot of third-party modules, some particular modules that are used in data science. NumPy is very big, pandas and scikit-learn are very big languages in the data sciences. Here's a public repository of all the packages available. Packages could be collections of modules. So here's a public repository of open source, sort of third-party licensed packages. And this is just giving you an indication of how many projects there are, how many files, how many different users. So there's an awful lot available by going to this PyPy site. When you want to make use of a module that's not a standard module in Python, you have to install it. And if you're on a Windows system, you actually install it through a Windows DOS, a DOS window, not through Python itself. But Python provides an installer program to do that. So it's not difficult at all, but it has to be done a certain way. So this is a link to information about installing packages. So it's referred to as, the installer program is referred to as PIP, Preferred Installer Program. There's other third-party installers for installing Python modules and packages. And then here's specific information for installing Python on Windows 10 that you can go to. Okay, so back to the features of Python or the characteristics. There really is a culture revolving around Python. And so there's this philosophy of the Zen of Python, that how readable code is really counts. Beautiful code is better than ugly code. Doing something explicitly is better than doing it implicitly. So an example of that might be, you might have a couple lines of code that do something specific, like maybe compute the mean of a set of numbers. And if you look at the code, you might put a comment statement in front of it to explain what it's doing. But if you made a separate function that's called calculate mean or determine mean, then that makes the code more readable by looking at code that's more explicit in terms of what it does, instead of having to look at the code and sort of implicitly, derive what it's doing. Simple is better than complex, but complex is better than complicated. If you ever look at the C programming language, or if you search, there's lots of sort of puzzles of C where they give a statement of C code where it's so complicated, cryptic actually. It works because C is very liberal in the way you can do things, but it's like a puzzle to figure out what one statement can do because of what can be done in C. I tell my students that C is a liberal language, C or C++. Java is much more conservative, for example. But C does try to let the programmer give lots of flexibility to the programmer, but Java is saying we want to keep code simple, and along with that is there should be one, and preferably only one, obvious way to do something. So like when I'm teaching and we say I equals I plus 1, but in Java and C++, you can put I plus plus to increment I. Introducing those two ways in a beginning course where you're initially learning the language just sort of gets in the way when there's multiple ways of doing things when you're trying to learn. So Python's philosophy is don't do things like that too much. There's a convention in Python of using what they call snake case by using underscores. So number of years would be written this way rather than capitalizing O and Y, which is called camel case. As an example of Python's goal of being readable, and or and not are written exactly that way, as opposed to Java, which uses the double ampersand, the double vertical bar, or the exclamation mark. And you've seen with the example I showed that Python uses print rather than something like system.out.println. And it even goes to the extent of being able to write numbers with underscores between them. You can use commas, but if you want to use underscores to make it more explicit, it allows for that. I think that's pretty unique in a programming language. So getting back to the culture, code that's Pythonic means code that's written in Python that uses the idioms of Python well. There's nice, elegant, readable, short ways of doing things. And then also you could fall back on the usual way that would not be Pythonic. So they call that code that's unPythonic. A Python programmer who really knows how to make use of Python and make use of the idioms well is called a Pythonista. So there's that terminology. So here's an example of non-Pythonic versus Pythonic code, or what they call unPythonic. Okay, what we want to do is we want to take, we have a set of names and a set of colors. And we want to pair them up. In Python, the for loop, we can say for this variable in this range. This is two lists. Names is a list and colors is a list. Those two lists are not necessarily have to be the same length. So what this is saying is take the minimum of the length of the names list and the length of the colors list. And whatever that minimum length is, call it n. Then we're going to loop in the range of, range n means we're going to loop where a variable idx is going to go from 1 to n. That's what the range function, it gives us a range of numbers to iterate over, a range of values. And they're an integer range of numbers. So int idx is going to be 0 and then 1 and then 2 up to n minus 1. And then we're going to print the corresponding name. So this is the index. So idx is initially 0. We're going to get the 0th element of this list and pair it with the 0th element of that list. F is a formatting syntax for formatting, we don't have to worry about right now, but basically it's going to print out what you see down here. Now, why is that non-Pythonic or unPythonic? It seems like the natural way to do it. Well, Python lets you iterate, let two variables iterate at the same time over two lists. Name iterates over the list names and color iterates over the list colors. So they're iterating in parallel. Zip is just a feature that was added that converts these lists into a form where they can be iterated over. But this is much more concise, and having these two variables iterate at the same time over those two lists is not unnatural. It's not cryptic once you understand the syntax that allows for that. And then that's a much more straightforward way of doing that than what we had to do up there. Okay, so that's just one example. There's a book that's good, inexpensive, that talks about Pythonic style code, which is only about $12 on Amazon. So the Hitchhiker's Guide to Python might be a good book to look at. There is lots of information online, so there's no need to really purchase anything, but that's one notable book and not expensive, like I said. Okay, so we said indentation matters. That means that white space matters. The white space we put, the blanks and tabs, do matter in terms of the semantics of the language. It's not just to make things line up and look readable. And I mentioned that instead of curly braces to denote a block of code, such as a block of code in a while loop, we use indentation, which means we don't need the braces. So here's an example. Java, while not quit, if selection equals 1, we do something. Okay, so we would have a if else, if something's true, else we could continue this. But this is just the basic idea of having something within the while and something within the if. Here in Python, the indentation tells us that the if statement is within the while. And the indentation, the next level of indentation, tells us that these two statements are within the if statement. So this is more numbers of line. You can move these opening curly quotes to the end of, this opening curly quote could be moved to the end of the while line. That's a style that's used. So this could be made a little shorter by moving them up, but still we have those curly braces. And this is more concise and readable. Notice we don't need parentheses around this condition either for the if. Okay. If a line is too long, if a statement is too long to fit on one line, there's a special character, continuation character, the line continuation character. So the backslash. So if I continue with this, I can use the backslash and continue on the second line with this long condition. If, though, there's a delimiter like print has matching parentheses, I can continue this on the next line without using the line continuation character because the right parenthesis denotes that delimiter denotes the end of the print. So in that case, I would need the backslash. I already mentioned that Python allows single quotes, double quotes, and triple quotes. So I can print hello world with single quotes or with double quotes or triple quotes. Mostly in Python, the style is to use single quotes because, again, it looks a little cleaner and more readable. It looks a little less cluttered. But for example, if I want to print a single quote literally as part of the word what's, then I can use double quotes as the delimiters and the single quote inside of it will be taken literally. So it provides an easy means to do things like that. The outer two could have been single quotes. I could have had a double quote literally in the middle. Okay. We already saw that triple quotes are used, are called doc strings. So we already saw that example. But another thing about triple quotes is they can span more than one line. So they're considered a doc string, but they also don't need quotes at the beginning and end of every single line. They span multiple lines. So that's why triple quotes are normally reserved as doc strings, and you would use single or double for regular strings. Again, if anybody has any questions along the way, just speak up.
So one question I do have,
Yeah.
what's the difference between doc strings and usual comments? Because I know in other languages like Java, comments are very similar to how doc strings work. And it seems like doc strings are very intuitive. So
Yeah, that's a good question. In Java, if you put certain characters within a string, it's taken as a documentation string. There's a Java doc utility that will extract all the comments that have certain syntax. Yeah, Java does it explicitly. The difference between this and regular comments is that, matter of fact, I may not have even mentioned the slides, but comments begin with a hash mark. And they're completely ignored by the language. But the triple quotes really do become part of the definition of a function in Python. That's why you can use the function name and ask, you could pass the function name of function name to the help method, the help function. And the help function, if you give it a function name, it looks up the doc string if there is one and displays it. Whereas comments are not at all part of what's going on. They're completely ignored. So that's the difference. But they function as Java doc comments in Java, the same purpose. And there's utility program you can run that will extract all the doc strings from a program and generate documentation, which is similar to what Java doc does in Java. Is that okay? Okay, so Python uses static typing, dynamic typing. We don't declare variables. So in a usual procedural programming language like Java, we declare the variable and we assign it. And we could do the two at once. So we're used to that. And if we try to put something in n that isn't an integer, it's going to give us an error. Java doesn't do that. Python doesn't do that. Python says when you declare a value to a variable name, at that moment, you've declared the variable name. The active assignment declares the variable. So n can be assigned the value integer 10. Then n, the same name, can be reassigned a float, and then that same name can be reassigned a string. And it's not going to complain about that because we can assign any type to a name. So each one of these overwrites the previous in terms of what's in variable n. So what is the type of n? It doesn't have a type, it's just a name. What does have a type? The values that are assigned to it. The current value of n depends on the current type of the value assigned to it. When it's assigned an integer, n's of type int. When it's assigned a float, now it's of type float. That's what's meant by the dynamic typing. Another thing is that all values in Python are stored as an object. So 10 is not just the number 10, but there's a whole object really being assigned. So, you know, if you know Java, you know that objects are stored as references. The variable stores the location of the object in memory. That's what's happening with all values in Python. N either has the value in it of the location of the object 10, or it has in it the location of this float object 12.8, or it has in it the location of the string object 12.8. And it can point to any object at any time. Okay, Java uses what's called duck typing. So duck typing is, if it walks like a duck and it quacks like a duck, then it must be a duck. So in duck typing, the type checking is not done at compile time. So let's say you have a function that expects a certain type of value to be passed to it. In Java, if you have a parameter declared type int, you've got to pass an int to that parameter. In Python, you pass a value to a function, and the function will go ahead and use it. Only if, when the function is using it, if it tries to call a method or tries to do something with it that can't be done, Then it will determine at runtime that there's an error, that there's a type mismatch, because you're trying to use it as something that it isn't. But it will let you pass it anything to a function. So, so to understand sort of the duck typing approach, there's three basic type systems. Nominal is the one we're familiar with. You declare variable I. You declare, variable I to be of type integer. Or you declare variable S to be of type string. You declare the name to be a certain type, and then you restrict it to only assigning certain type values to that variable name. So that's what we're familiar with. Structural, well, let's go through. So I mentioned nominal. And so that's what we know. That's statically determined what the types of these are. It's determined at compile time. It's going to know what types these are because it's declared. Another approach is you can have two different types, but they're compatible if each has the same feature as a second. So if you had two classes with different names, but they had the exact same members and methods, they could be considered the same type because structurally they're the same. The names can be different, but if they're structurally the same, they can be considered the same type. Whereas in the nominal type, if you have two classes with each a different name, they're not the same type because they're not the same name. So in duck typing, it is related to structural type systems that two types are considered the same if they have the same structure. So in other words, they both have the same method names. So we have class A and class B. They both have a method A. They both have a method B. And if the code you give it to is expecting a method A and a method B, you can send either one of them to that method or function because they're expecting to call a methods called A and B. So that's determined at runtime. Only if you pass it an object which has a method A and a method C, and then that method tries to call method B on it and it doesn't exist, then at that time, it determines that they're not compatible. So that's what duck typing is. So here's an example. We have three different classes, and we have within each one a function defined to fly. We can pass either of these objects to code that is going to tell that thing to fly and call the fly method. This doesn't have a fly method, but it will let either of these objects be passed to it, and then at the time where it tries to call the fly method of the whale, since there isn't one, then we get an error. So it would be able to say robin flying, sparrow flying, and then we would get this error. Okay. So a little bit more under the hood of Python. We said it's implemented in the C programming language. So the interpreter, the standard Python interpreter is written in C, which means that certain things in Python can run pretty efficiently because some of it's implemented in C. This standard interpreter is called the C Python implementation. You are able to incorporate code written in other languages because Python provides this foreign function interface. So within Python code, you can write C code, which would definitely run more efficiently as part of Python, but you could actually write code in other languages because of this foreign function interface. So that's something you could do with Python. There's other implementations you probably run into if you look at Python. There's a version of Python that will run on the Java virtual machine. So what that means is you've written the program in Python, but it's translated into the bytecode of the Java virtual machine, and you can run it in the Java environment. So that's called Jython. Iron Python is the version where you can run it on Microsoft.net. So you can translate the Python code to run in that environment. And then there's something called PyPy, which is a way it actually compiles. It's a just-in-time compiler, which is what Java does. It takes certain critical sections of the code, and instead of the interpreter executing the instructions, parts of it are actually compiled to your local machine code and executed to speed up execution. So if you're not clear on an interpreter versus a compiler, an interpreter is a program that's given instructions of a language, and that program reads them and produces the result. So what's actually executing the instructions is another program. A compiler translates a program all the way down to the machine code of your processor. So what's actually running is the machine code that the processor, the hardware processor directly executes. So if you compile a program down to the machine code and the hardware is running those instructions, that's going to run generally much faster than if there's a program interpreting and running the instructions. But Java is interpreted, and it's designed in a way that still lets it run pretty efficiently. So what we're talking about here is that Python's the type where the code is read by this Python program like CPython, and that program is determining what the instructions are and producing the output. And so what's PyPy is a way to actually compile it if you wanted to have it really run efficiently. But if I get to the end, I'm going to run a program that processes pixels in an image, and it does it pretty quickly, and there's lots of pixels in the image. So it can be, it is still pretty efficient when it's interpreted. Some others are Python for running in a browser, Ruby Python to run with Ruby interpreters, the language Ruby, and MicroPython to run on microcontrollers. Then there's another thing called Cython, which is not the same as CPython, but it allows you to extend Python by implementing your own C code and actually extending what's in the language. But just to mention those. Okay, so I said the data model is important. So what does the data model look like? Types are talked about in a general way, almost more mathematical way. There's numeric types, there's sequence types, there's iterator types, mapping types, and set types. Under numeric, it's what we would expect, int, float, but you also can have complex numbers, imaginary numbers. Any object you create, any class you can create, you can make behave as a Boolean. There's a special method you can implement to make any object be able to be treated as a Boolean. Sequence types are a big part of Python. Sequences can be lists, which is a list of values that can be updated and changed. A tuple is a list of values that cannot be changed once you create the tuple. Lists and tuples can have any type of thing in it. They can have integers, floats, strings. A list can contain lists, so they could be nested. A range is a sequence type where it's a sequence of numbers that are produced as you need them. So before we had the example of using range. So if you say range from 1 to 20, it doesn't generate 20 numbers. It generates each number one by one as you need them. So if you need a large range of numbers, instead of them taking up memory and being stored, they're generated as needed. And then text is a sequence of characters or text, which is what we think of as a string type. Now, what's nice about, one nice thing about Python is all these sequences have common ways of doing things with them. If I want to iterate over all the values in a list, or I want to iterate over all the characters in the string, it's done exactly the same way. because they're both sequences. So we'll see. So lists have square brackets with the items separated by commas. So that's a list of numbers, a list of strings. In the Python interpreter, if you just type this or assign this to a variable name, you could just produce a list. Lists are mutable. So like array access, I can change one of the elements in it. So I can modify lists so they're mutable. Lists can be nested, like I said. You can have a list of lists. And then tuples are used parentheses instead of square brackets. So if it uses parentheses, these values cannot be modified. There's another advantage to tuples too, is that they can be used as key values for looking up in dictionaries, and what are called dictionaries or like hash tables. But there's certain ways tuples can be used that lists can't. Even though they seem restricted because they can't be updated, they have other advantages. So they're immutable. So if I try to change a value in a tuple, I can't, it's not allowed. Okay, those are two big of the data types in Python. There's common operators for any sequence, like I was saying. So how do you access a particular character of a string or a particular item of a list? It's done the same way. I can check if something's in a string the same way I check if something is in a list. I can get the maximum or minimum value of anything in a list, or a string, anything that's a sequence. And I can get how many are in that sequence. So in Java, the way you get the length of an array is by calling a variable length, dot length with no parentheses. And the way you get the length of a string is dot length with parentheses, because that's actually a method. So this is very consistent in how you do things. This is a feature that's, I think, pretty unique to Python. You can do what's called splicing of lists. I can take any sub-list of this list in various ways by using this syntax that's provided. So if I want to get the values from index 2 up to, but not including index 4. So index 2 would be 30, 0, 1, 2. This goes up to, but not including index 4, so 30 and 40. If I want to include, I think I made a mistake here. This second 2 shouldn't be there. I want to start at index 2, and I think that should have been -2. Start at index 2 and then go to the last item in the list. I can do that. This allows me to take a subset, which is all the index values incremented by 2. So index 0, index 2, 4, 6, 8. So I can select out just those index values. This would give me everything in the list up to and not including index 4. So I don't have something before the colon. So that means I'm starting at the beginning and going up to, but not including index 4. So 50 is index 4, so it went up to 40. I can produce a list backwards by using this syntax. And if I want to delete the even index values and produce what the remaining ones were, then I'm deleting the even index values 10, 30, 50, index 0, 2, 4, 6, and it's giving me what's left. So there's lots of flexibility in what you can do with splicing lists. This is what I mentioned before about having the range function, which will generate numbers as you need them and not store them all. So when you want to iterate over something and you need an index value, you just say for I in the range, and whatever range you want, starting at 0 up to but not including 10. this will print those numbers. So it's different than what we would do as a for loop in Java, for example. Oh, we already talked about this with strings, but it's a sequence type. But we know about the ways to denote a string. What I was saying before, you can iterate over a string the same way you do over a list. So if I have this list and this string, I can iterate over the list of numbers this way, and I can iterate over the characters in the string that way. So it's the same way. Actually, I had written a program where I was supposed to iterate over a list of strings, and then instead it was iterating over the characters of one string. And I realized right away that, that what my error was, but it went ahead and iterated, but it iterated over the string rather than the list of strings. This is something really, let's see if we get, list comprehensions are something, also something really useful in Python. This feature exists in other languages, but it's still pretty central in Python. And I gave a good reference for using list comprehensions. So list comprehensions are kind of turning a for loop inside out in a way. What I can do is I can say, I want to generate a list of values. So I got these square brackets. I want to iterate X in the range 1 to 8. So the range goes up to, but not including 8. So this will iterate 1 through 7. This is saying, I want to square every number that I iterate over in this range. I want the result of X squared. This is what I want to be in the list, the resulting list. I want, each time I iterate, what I want to put in the list is the square of X. So I produce square numbers. There's a lot that can be done with list comprehensions. I can even have conditions. I can say, here's a list that has negative numbers in it. I want to produce a list without those negative numbers. So what I say is, let's iterate X in the list of nums. What I want to put in the list is literally X. But I only want to put X in the list if it's greater than 0. So I'm going to put X in the resulting list for each X in this list as long as it's greater than 0. And that's what I get. This is a way to create a list out of a number. 1248 is an integer number. I've converted it to a string with this string cast operator. Now that it's a string, I can iterate over strings. And for each character iterated over in the string, I'm putting in the list. So, oops. So I ended up with a list of characters for that string pretty easily. So that's pretty powerful. Obviously, lists and tuples don't have a fixed length like arrays. They have an arbitrary length. So you don't have to worry about the maximum length. You can delete from them, insert, append to them. But if you know about linked lists and arrays as a way to represent lists, this is really under the hood represented as a linked list, which there's a certain amount of overhead in implementing it that way, but it gives you flexibility. If you really wanted an array, which would have faster lookup access with the typical benefits of an array, there is an array module that you can use, an array type in Python you can use if you want, but the normal type to use is a list because of its flexibility. Oh, and there's a built-in function sum. So if I want to add up the sum of these sublists, I have a list of lists. If I want to have a list which is the sum, the total of each of these lists, I can have a function sum where I'm saying for each list in this list of lists, take the sum of it and make it the value in the resulting list. So the 6 is the sum of 1, 2, 3, and 15 is the sum of 4, 5, 6, and so on. So it's pretty flexible. Let's see, I had some demos, links directly to the Repellent site, but let me try. Oh, that didn't take, that took me to something else we want later. Okay, so I'll skip over that, but there's links if you want to go to them. Those are public that you can go to. So we talked about the fact that the range function is a generator. So generators are a type in Python. So we talked about the range function. So I can do things like start at 2, up to, but not including 100, or no, you can add a step. So I can say from 2 to 100 by 2s. When you give a step, then it does include the last number in the range. But if you don't give a step, then it goes up to and not including 100 here. But anyway, you can have a step. But the point here is you can write your own function that works as a generator. It will produce a sequence of numbers one at a time by use of this yield keyword. So this one says it will generate the first n integers based on what n it's given. So n is, if I give it 10 as n, it'll start at 0, up to, and not including 10. It will yield the number when it's, basically return it when it's needed, and then I increment for the next value. So I can print the sum of these first 10 numbers, but all 10 are not in memory at once. They're given one at a time so that they're not stored and summed up and given the result. So the fact that you can write your own generator is pretty unique, a unique feature of Python. Okay, so we went through lists and tuples. Another big data type in Python is what are called dictionaries. Dictionaries relate to hash tables. It's a way to look up a value by a keyword. It's instead of looking up a value by its index number, you're able to give it a name, a keyword or name, and it looks up a value associated with that name. So generally that's called a mapping type in Python. So they talk about mapping types, but the only mapping type there is in Python is a dictionary type, the one standard type. So here's an example. If I wanted to store how many days were in each month, I would normally put them in an array, and I'd have to know that index 0 was how many days for January, index 1 was how many days for February. But with more of the hash table approach, January is the key that I use to look up how to get how many days for January. And February is what I use as the value to look up how many days for February. So instead of putting an index number in here, I put the keyword. So that's something that's the basic dictionary type in Python. Dictionaries are used a lot in the Pythonic approach to things. Now, I mentioned before that tuples were immutable, and there's an advantage to that. The key here could be a tuple, which might be a birth date. So the key could be a tuple, which is the month, day, and year of somebody's birth date as the key. because a tuple is immutable. I couldn't do that with a list of values. So this key can be kind of more of a complex value as a lookup, or what's returned can be a complex value too, not just a single value. Python uses the assignment statement for assignment, but there's some things that are a little bit different. You can say XYZ equals 10, 20, 30, and it does those 3 assignments at once. So is that good style? You know, should that be allowed? This is not what you're allowed to do in most languages. So if you're teaching Python as a first language to students, you may not want to introduce this because they may feel like that's normally able to be done in languages and it might mislead them. But once you're an experienced programmer and you realize this is just a convenient thing you can do, it's convenient and it's still very readable in terms of what it does. You can also assign a sequence to a sequence. So these are 3 individual variable names and 3 individual numbers. If they were in tuples or lists, I could do the same thing. So if there was a name for this tuple and a name for that list, I could do the same thing. It will do a 1-to-1 assignment. Python, because it believes in one way of doing things, has an if statement, but no switch statement. Switch statement, an if can do everything a switch can do. A switch is just a more shorthand convenience, but Python says we always do it as an if statement or if else. Has while, doesn't have do while, which is another variation. It has while. The for statement, it has break and continue, which lets you break or continue in a loop, which sometimes is looked down upon in terms of good structured programming style, but it has it in Python. And it has this special instruction pass. That instruction does nothing. So if you've taken assembly language, you know in assembly code, there's a no-op instruction, which you use to take up space, but it doesn't do anything. Python has this similar idea of having a pass statement. When you want to have a statement for some reason, but there's nothing to do really, you just need to have a statement there, you can put the pass. So some examples. Oh, where'd my examples go? Okay, I thought I had examples. I thought you could put a pass in a while loop and that makes it an infinite loop. But in the loop, it might be waiting for something to happen, like some kind of keyboard interrupt. So you might have while and have pass in it, and then you're looking for a keyboard interrupt, and it will loop until that happens. Another thing you can do is if you're defining, if you're writing a program and you've decided what the functions or methods are, but you don't want to implement them yet, but you want them to exist, you can declare a function or method and put the function header, but the only thing in the body can be pass. So this way it's defined and it exists, but it doesn't do anything yet. So that's another use of pass. So we do everything with if or if else. We don't have switch. And there's a little shorthand in Python where the else if is combined into one keyword. Again, we don't need parentheses around conditions. So if selection is 1, we do this. Else if selection is 2, we do that. Else we do that. Iterative control with loops is what we would expect while to have. I can iterate until a condition is false while something is true. I can iterate through a range. I can iterate through numbers from a sequence or list, and I can iterate over the characters we know in a string. Here's the example. I define a function, but I'm not ready to implement it. I can put the pass instruction there, and then Python won't complain because now it's considered implemented. And here's the example of while pass. If I want an infinite loop, and then within the loop, I might be checking for an asynchronous event, like a keyboard, a keystroke, or some other asynchronous event. Okay. Reading input from the keyboard. Everything's read as a string. I just say input. The prompt I want for the input is part of the same statement. So I don't need a separate print and a separate input statement. That's the prompt. It will read it as a string, put it in that variable. If I want it to be read as an int, I just put int in front of it to typecast it to int. And now I have the int. And to print, we saw you just print any string. And you can print things with commas separated between them. So I can print any number of things separated by commas. I don't have to concatenate them into one string like Java. So there's a lot of, there's a set of useful built-in functions that are available. This is just a look at some of them. There's that help function, the length function, which applies to different types of things to get their length, the length of a string or the length of a list. We saw a range. I could determine the type of something. You can actually execute Python code. You can actually have the user type in a Python instruction and read it as input and then execute it as if it's an instruction. You can do the same thing with an expression. The user could type in an expression, you could read it and then evaluate it, or the program could create its own expression, or the program at runtime could create its own instruction. It could create its own instruction and then turn around and ask it to be executed. That's something that can be done with an interpreter. So anyway, that's some example of the standard built-in functions. A module in Python is simply a file. So a separate Python file is its own module. One of the modules would be labeled as the main module to start things off. Each module has its own scope. So if a variable is declared within a module, within a file, but not within a function, it's considered global to that module. So if I have a file with 5 functions in it, but I declare a variable at the top outside of all those 5 functions, then that variable is global to those 5 functions. And by declaring, we don't actually declare variables, but I mean defining. If you set a variable name to a value, that's when it's declared or defined, when you first assign it. So here's an example. If all of this were in one module, one file, tax rate would be global because it's not assigned within a function. So any part of this program can access it. But from within a function, to access a global variable, you have to declare it and say, look, I'm trying to access something which is global. I'm not trying to use something that I assigned in my function. So this function can have its own variable called tax rate. Well, this is a way to say I want to access the global variable, and now we can access it and use it. Why did I put this in all uppercase? Because that's typical in programming. This is meant to be a constant, so it's in all uppercase. In Java, we would also put that all uppercase, but we would declare it to be a constant variable, and then it couldn't be changed. In Python, you can't force this to be unchanged. There's no declaration saying this is a constant. It's implied by the caps. This could still be changed. So that's not as airtight as what we would have in Python, but we can't declare variable types. So we just have to show the intention. And then I can access tax rate down here in the main because this is global to all this. So that could be, this could be a module, that one file. Python has a lot of flexibility in how you pass parameters. There's 4 basic ways. Positional is the way we're used to. Keyword you may have seen, and then there's 2 others that are more flexible than the first 2. So we're familiar with positional arguments that let's see, what did I do? Oh, yeah, yeah. So I created a list in the main, and I'm calling this function range1, and it wants 3 parameters. I'm giving it 3 parameters. Again, we don't declare the types of the parameters. So I could actually pass this anything I want, but when it goes to use them, if it doesn't have what's needed for that variable, then I get the type compatibility error at runtime. So I give it 2 ints in a list, which is what it's expecting to get. And using list comprehension, I'm producing a list of values that are only between the min and the max. So I gave it a min of 20 and a max of 30. I wanted to take a subset of this list and return a list which is only those values within that range. So it's going through the list for each I in the list I gave it, put I in the list if it's within that range. What do you see that's a little bit funny about this statement, the return statement? Or what's in the return statement that doesn't look right? Does anybody see?
Wait, the return statement's a for loop.
Well, the for loop's going to happen first until the list is produced. Then when the list is produced, it will return the list. So the for loop is within the list. That's why I said it's kind of like an inverted for loop. So it says for each I in this list, one by one, put I in the list, the resulting list, only if it's in this range. So what's funny about this? If I is greater than or equal to min and less than or equal to max. We normally can't do that in languages. Remember, we have to say if min is less than or equal to I and I is less than or equal to max. We have to have an and check these two separately. Students will sometimes do it this way because it's natural math in mathematics, but normally it's not interpreted the right way when we write an expression like this, but Python lets you do that. So again, it's a little more natural to be able to do that. Okay, so that's just showing that's the regular kind of arguments we're used to, positional arguments, but again, showing some Pythonic code, how things can be done. We can have keyword arguments. So in this function range2, we have min, max, and values. So when I call that function, instead of putting them in the right order, I can put them in any order I want if I indicate their name. So now I'm calling range2, and I'm saying min is 20, max is 30, and values is equal to list1. Or I can say, I'm calling it, and I'm going to give you values first. Values is going to be passed as list1, min is 20, max is 30. And even though this is not the right order, because I'm using these keywords, it will match up with what I give it. So I have to know what these dummy parameter names are to be able to do this, right? But that's nice if you can't, like, suppose you can't remember if min or max comes one, which before the other. Then you might just use the keywords and not worry about it. So that's what's called keyword arguments. You can't put keyword arguments before the positional ones. The positional ones have to go first. So if I put keywords for min and max, and then I put values as if it's the third one positionally, it's not going to like that. Okay. Let's see. Okay, so that's that. So now the real flexibility here is we can call functions with an arbitrary number of parameters. Here, function average. I have values, but I put in front of it an asterisk. That means it will take any number of values of what I give it. I could give it a list of strings, a list of numbers. I could give it 8 different variables. It doesn't care if I give it values as separate variables or in a list. It allows for the flexibility. So here in the main, because of that, I can take the average of 2 things, of 3 things, of 6 things, and that same function will work for any number of parameters because of the asterisk. How can I do that? We don't have to know how many are in there because we use the for loop. We say for each value in this collection of values, right? Whatever this was, for each one in that group of values, do this. So I'm keeping count of how many. I mean, I'm adding them up and I'm keeping count of how many. And when the loop's done, I do the division and I've got the average returned. That's really flexible. This is an example of a function where I want to filter out the negative numbers like we had before. I want to give it a list and have it return to me the list with all the negatives removed. So here's the list comprehension approach. For each I in the list of values, return I in the resulting list if I is greater than or equal to 0. This will accept, I made 4 variables in a list. I could call this with 2 separate variables, num1, num2, and it'll take it. I can call it with 3 or 4. I can call it with a list of values, and it will take that. You do need the special syntax of the asterisk here before the list you're passing. That will unpack the list into all the separate values for you to be passed to this, because this expects a collection of values. A list is really one value, but this unpacks the list into all those separate values to be passed to this guy. So as long as I know that syntax, I can pass a list or individual variables to that same function. And then, you know, the function itself was very simple to write. And we can do a similar thing with dictionaries, but I left that if you wanted to look at that. But that's the 4th major type of function where it can be passed a dictionary rather than a list of values or a collection of values. You can return from a function a single value or multiple values. I can write a function that returns 10 and 20, both of those values. Well, remember, we can have multiple assignments at once. So I can say num1 and num2 simultaneously get assigned to the 2 values that come back from multiple values. So when I call this, what I'm really getting back is a tuple of those 2 values. So if I call that function and assign it to a variable and print the variable, I see it's a tuple. And there's a way to find out the type of a value by using the type function. So if I print out the type of this variable, it's going to say it is of type tuple. It's a class, but it's of type tuple, and we can see that it is. But the point is that we can return multiple values from a function, or we could, of course, package it into an object that has those multiple values. We already talked about the doc string. So here with this function filter negatives, if I have triple quotes as the very first thing in the function, doc strings have to be the first line of the function or the class or the module. It will use it as a doc string. So if I say help on the name of the function, it will print out all of this about the function. It exists in module main, and then the function header, and then the description of what it does. Okay, so let's look at the feature of being able to treat functions as if they're values like we treat other values. that they could be assigned to variables and they can be passed as arguments to functions. They're called anonymous functions because we never give the function a name. It's the description of a function without naming it. Let's see, what did I do? Oh, well, we're talking about functions. So we know about the built-in functions. There's a special notation of the double underscore before and after a name is used by Python, and they call those dunders, but that's its way of naming certain things that are sort of essential things in Python. Just mentioning about the naming. So if we pass a function to a function, the function receiving the function is thought of as a higher order function because it's a function that's operating on a function. And here's a reference I gave you for this. So here's an example. Here's a function called shout that will shout out whatever message you give it in parameter text. So this is going to return the uppercase version of the text you give it. And that's what it does. Whisper will return the text that it's given in lowercase. So these are two functions. Here I have a greeting function that will print whatever you give it. Now I could give this, if I get, we know there could be a function like this where we give it a string, a particular string, but I can give it a function because maybe the function, there's a lot to it to generate the string that should be displayed. This is straightforward, but the function can be arbitrarily complex. And so I could say, here's a function that you execute, which will produce what you should print. So it takes what we give it, and it thinks of it as a function. It's expecting to be given a function. So when we call it, we give it either function shout or function whisper. Whatever function we gave it, this is what it calls it. And it says, I'm going to call the function on the string, on a particular string. So it could have been given the string and the function to use, it could have been given the function and then a particular string variable, but here it's hard coded, but it will display this based on the function we gave it. And so if we give it function shout, it does it uppercase. If we give it function whisper, it does it lowercase. So again, this is just the general mechanism of how you pass a function, but the idea is that the function can be pretty complex in terms of what it does with it, in terms of what the function does. So that would make greet a higher order function. I can assign a function to a variable. So, well, I'm applying this function to this string, and the result of it I put in a variable, and then I can print that. So, this greet function can use a variable if it wanted within the function. So I wasn't going to go over classes, but I said every value in Python is an object. So the types of objects we're going to have are numbers, booleans, all of these types. Functions themselves are objects and modules are objects. Basically, everything is an object. We can find out the particular ID number of any object by using this function in Python. So if I'm on the shell, the Python shell interactive window, I could type this in and it would give me this number or some number. That's telling us that even constants are objects. If two variables are assigned to the value 10, they're both equal to the same object 10 in memory at that point. But I can always see, this is the literal value true, false in Python, and I can see the location where that is stored. There's a special value none in Python. It's kind of like when we have null in Java, but none is a value that you can always assign to a variable or return from a function, which kind of means it doesn't return anything, but it returns none. But if you want a function or variable to be assigned or return something in every case, it can return none. If you want to find out all the methods that are available for a given object, constants are objects. So if I want to know all the functions available that I can apply to variable n because it's equal to integer 10, I can use the dir method of function, and it will give me a directory of all the methods available for that type variable at the moment. So this list would go on with what I could do with it. Or I could directly do it with the value. You know, I can directly ask the value what kind of operations could be used on it, or the variable. We know in Java that objects are references. We got to be careful when we use the equal and double equal sign. But in Python, double equal always compares the reference values, the locations of objects. No matter what kind of object it is, everything's an object. Whereas in Java, primitive types like 10 would not be an object. So in Python, everything's an object. So everything you compare with double equals is going to be comparing the location of those objects. If you want to see if the locations are equal, you use is to see if two objects are actually the same object, that it's two names for the same object in memory. Let me see what I'm sorry, I said it wrong. The double equal compares the dereferenced values. So the double equal will compare the values we want it to compare, not the locations, but the actual values in the objects. So that does what we want it to do normally. If we want to know if it's two names for the same object, then we use is. So in this case, we can use double equals on two fractions. And if they both have the same values in those two separate objects, it will come back true. If I want to see if they're actually the same object in memory, I can compare their ID number. Is the ID of this object the same as the ID of that? And that'll be true only if those two variables are equal to the exact same object. And then instead of doing that, I can also use the is. The is the same as comparing their ID locations. Are they exactly the same two objects in memory? And here's an example in Python interpreter. If you type, in, you get those results. There's a link on something called sequence unpacking you could look at. I'm looking at the time. Let's see. So these are the dunder namings, that these special values that can be used with the double underscore in the beginning and end of it. Let me see. So modules, I said, are just a file, and a file can be a collection of functions, a collection of classes, a mixture of a collection of variable assignments. So a module is any collection of code that's being kept in a separate file. And you import modules like you import modules in Python and Java. Here's some references again to modules in Python. I'm going to skip over this because I want to. Every time you execute a file in Python, it gets compiled. So the source code is .py. The compiled version is .pyc. So every time you run a module, it's automatically compiled in the sense that it's compiled for the interpreter to execute. And that version stays around. And next time you run it, it will use version that's already compiled unless it's been modified since this time, and then it will recompile. So compile, again, is compiling it into intermediate code, which is the executable code for the interpreter. It's not compiled code down to the machine code. Packages are a collection of modules. So a package is a collection of files, and each file is a module.